Change in the state of matter from one phase to another phase at a constant temperature is known as change of phase of that matter. Example, melting of ice cube, solid state, to water that is in the liquid state. Latent heat of matter is the heat energy needed to change the phase of that matter. In this topic, you will be learning about the specific latent heat, the specific latent heat of melting, the specific latent heat of vaporization, and other interesting facts that you will observe in the day-to-day life due to the change in phase and the latent heat. Hi everyone, welcome to Study with Akshay, and this is Akshay. In this particular video, we will be learning the topic which I told right now. So let's not waste time, let's get started. First topic is specific latent heat, which is abbreviated by the letter capital L. It is the amount of heat required by the unit mass of a substance to change its state without any change in the temperature. You can view the same on the screen. And it is also given by the formula Q by M. Q is the heat energy or the heat capacity divided by the mass. Next topic is latent heat. Latent heat, it is nothing but the heat released or absorbed by a chemical substance during the process that occurs without a change in temperature. In this case, temperature is maintained constant and the heat energy absorbed or released by a substance is known as latent heat. It is abbreviated by the letter Q. Q, why it is only Q? It is because it is the heat energy. Basically, it itself is the heat energy. Like in the specific latent heat, it is the amount of heat energy, and it is with respect to time. Here it's not compared with time, it is the energy itself, right? The energy which is released or absorbed by the substance, keeping the temperature as the constant. And this you can see it is nothing but the substituted version or the transformed version of specific latent heat itself. Next topic is specific latent heat of melting. It is indicated as L suffix M. It is the quantity of heat required to convert the unit mass of a substance from solid to a liquid state as its melting point without any change in the temperature. At its melting point without any change in the temperature. It is basically the heat energy required to convert unit mass of a substance from solid to liquid state at the melting point. What is the melting point? What is melting point basically? It is the point at which solid converts into liquid. Okay, for that particular substance without any change in the temperature. Next, specific latent heat of vaporization. It is indicated by L suffix V. It is the quantity of heat required to change a unit mass of a substance from the liquid state to the vapor state at its boiling point without any change in the temperature. So let's assume this is for the water itself. What is the boiling point of water? Boiling point of water is 100 degrees Celsius, in which the liquid will be converted into vapor. Water liquid will be converted into water vapor at 100 degrees Celsius. So that the amount of heat energy is nothing but known as specific latent heat, which is required to convert the water from liquid state to vapor state. Next, the phase change in naphthalene. What is this naphthalene? It comes as white color balls or pink colors balls, you will get it. That gives a fragrance. rather, and later on it actually converts, which is in the solid state, it converts directly into the vapors. There won't be any change in the liquid state. Let's see what it is. The temperature does not change when the change of phase occurs, although the heat energy is absorbed during the melting, and heat energy is rejected while freezing. The melting point and freezing point are the same for naphthalene. So as a result, it changes from solid to vapors. Factors affecting the melting point. So first factor is effect of pressure on the melting point. Pressure is the first factor. The melting point of a substance which contracts on melting. That is, for an example, if I start explaining while saying the definition itself, it becomes more and more clear. For example, if you take ice melts, or the uh, the amount of melting point decreases due to the increase in pressure. As the pressure increases, the height, the melting point of ice starts decreasing. Pressure is inversely proportional to the melting point. So here again, the melting point of the substance which expands on melting, that is, for an example, let's take wax. It increases with increase in pressure. So melting point, it depends upon the substance. Basically, here substance we are taking it as ice, and here on the other way around, it's contracting. Ice keeps on contracting as the pressure increases, whereas like wax, if you take, it keeps on expanding, whereas pressure increases. So it depends upon the substance. Next, effect of impurities on melting point. The melting point of substance decreases by the presence of impurities in it. It decreases if impurities are more. This is utilized for making the freezing mixture by adding salt to ice. Anyone might try this in home. Whoever watching this video, you keep a cube of ice cube, and then put a small string on it and add salt on it. Then you observe, your observation makes you analyze the concept of impurities. Salt is taken as an impurity over here. Okay. Salt to ice, which decreases the melting point of ice from 0 degrees to 12 degrees Celsius. Minus 22 degrees Celsius, sorry. So how much we can also memorize right now. So, but don't say the same reason for an examiner, because this is your duty to memorize as far as my duty. So we will be making many videos per day, so henceforth the degrees might change. Rather, I have told almost all are correct. Minus 22 degrees Celsius. It's 0 degrees Celsius to minus 22 degrees Celsius. I'm sorry for the inconvenience also. Right. Yeah. Next, factors affecting the boiling point. First one, again the same two factors, effect of pressure on boiling point. The boiling point of a liquid increases if the pressure decreases. Increases with the increase in pressure and decreases with the decrease in pressure. So they are directly proportional. Boiling point is directly proportional to pressure. Next, effect of impurities on boiling point. The boiling point of liquid increases in the addition of impurities. As the impurities increases, it increases. Boiling point also increases. Addition of a little common salt to water increases its boiling point. Common salt is again considered as an impurity, so as a result, it increases the boiling point. Next, natural consequences of high specific latent heat capacity of ice. So what are these consequences? These are again a give reason question. Wherever consequences, advantages, all those things are given, they are all give reason questions. Snow on a mountain does not melt as a whole, but melts gradually into a water with the heat of sun. Why is it so? This is because Ice has high specific latent heat. Ice has high specific latent heat. Next one, water in the lakes and ponds in the cold places do not freeze all at the same time. Why is this so? Again the same reason, ice has high specific heat. Okay. Next, drinks are cooled or more effectively during ice pieces at 0 degrees Celsius and not by water at 0 degrees Celsius. Why is it so? So if you take a Coke bottle or a Thumbs Up bottle or any cool drinks bottle, you keep it in water. uh, one bottle you keep it in water, one bottle you keep it in ice. When you take out from ice, it still remains cold, whereas in water it won't remain cold. Why is it so? Because ice has ice specific latent heat. Next, consequences of high latent heat capacity of steam. Steam causes more severe burn than boiling water, although both are at 100 degrees Celsius. Why is it so? Because steam has high latent heat capacity. If you add a word specific latent heat, then it becomes completely wrong. And don't ask the teacher, whoever has evaluated your paper, whoever distributes your paper, just one word is missing over here, so please do give me the marks over here. No, it completely changes the physics meaning behind it, so that cannot be accepted. The steam is used for running trains or uh, machines because the high amount of heat is contained in it turned into a mechanical energy. Why is it so? This is again a give reason question. Why is it so? Because steam has high latent heat capacity. So as a result of this, it is used in running trains and machines. It is released during running trains and machines. So heat is contained when the machine is turned on, and as a result, mechanical energy is converted into heat. Okay, you can write all these things, or rather, this becomes a cock and bull story again. So instead of this, steam has a high latent heat capacity. So one thing which I can give a clue over here, for these two things, they have only given it as steam. So you no need to identify what is this constant. You can write heat capacity, high latent heat capacity. Since water has highest specific latent heat of vaporization, water from the soil does not evaporate quickly by heat of sun. Why is this? Since water has high capacity, why does it not vaporize so fast? This is because steam has high latent heat capacity. We are almost done with this chapter now. We're done with this chapter. Actually, one more part is there which is not given in few of the textbooks. In few of the textbooks, they have mentioned another part known as global greenhouse effect and global warming. So people who are referring the other textbooks uh, except Selena, because in Selena textbook where I refer, they have not given this topic. So it's fine if you skip this topic also, because most of the questions won't come from this topic. So as a result, I am voluntarily saying the next topic is not important. Though it's not important, it's my duty because in some of the textbook it's given. So I will be doing the next topic where there is greenhouse effect and global warming. That becomes the video 3 of this chapter. And people who don't think in their schools or in their respective institutes, they have not taught this topic, can just glance through the topic, and more or less that will be less than an half an hour video. As you all know, I don't exceed half an hour while doing videos in order to not make people feel bored. So that's end of this video, and then let's meet up with the next video of greenhouse effect and global warming. Thank you. Stay home, stay safe. If you have liked, please click on the thumbs up button. Please share this video. Please post your reply in the comment window. Thank you.